Hello friends, I'm Ronak Kapoor. Today we'll discuss the number systems and the divisibility rules that come under number systems. Divisibility rules will always and always be a very deciding tool with you always in your quant, throughout your quant. There are divisibility rules for most of the numbers that come under the category of say 20, and those tools are sufficiently enough for all your practical purposes as long as the aptitude exams are concerned. I have made these clusters for all the numbers that have similar rules of divisibility. That is 2, 4, 8, 16. They have got similar tools, similar rules for the divisibility. Similarly, 3 and 9 have got somewhat similar rules. And in the same way, 5, 10, 11, 13. So we'll discuss all these clusters one by one. Let's start with the first cluster. The digits 2, 4, 8, 16, 32, 64 and so on will belong to the same cluster. What happens usually is, when we want to find the divisibility of 2, that is, if we have a number and we want to find that if that number is divisible by 2 or not, we take that number and we check only the last digit of that number. Similarly, for checking the divisibility with 4, we check the last 2 digits of the number. Let that number be how much ever big, we will see only the last 2 digits. If that last 2 digits are divisible by 4, we'll say that the entire number is divisible by 4. Consider over here, take any big number, say 5 4 6 8. Okay, so we'll take only the last 2 digits, and if the last 2 digits, that is 68, is divisible by 4, then we'll say that entire number is divisible by 4. And in the case of 8, in the case of divisibility of 8, we'll take the last 3 digits, and in the case of 16, we'll take the last 4 digits of the number, and for 5 digits for 32 and so on. But now we need to understand that why does this happen. This happens because while considering 4, that 100 is a multiple of 4. So every 100, the above number, I can split this number as 5400 plus 66. 5400 being a multiple of 100 will always be divisible by 4. And if we see only the last 2 digits, that is 68, we'll be able to make out whether it is a multiple of 4 or not. The entire 68 over here is a multiple of 4. Similarly, if in case the last 2 digits is 08, then 08 is a multiple of 4. Then whatever digits be here, that is immaterial, but the entire number will be a multiple of 4. Similarly, 8. For 8 also, we'll say that we'll see the last 3 digits, and 1000 is a multiple of 8. See, I have mentioned over here, 100 is a multiple of 4, 1000 is a multiple of 8. Second cluster that comes is 3 and 9. In the divisibility rule of 3, we have a very big number. Like here we have considered 654321 is a very huge number. If we want to check whether this number is divisible by 3, rather than going and individually practically dividing it by 3, we have a rule. If we add all the digits of these numbers, that is 6 plus 5 plus 4 plus 3 plus 2 plus 1, we'll get a sum of the digits. Sum of the digits in this case is 21. If this number 21 is divisible by 3, the entire number will be divisible by 3. That is, for any arbitrary number, if we add the digits, if that sum is a multiple of 3, then that entire number 65321 will be we can conclude that it is a multiple of 3. Consider any other number, that is 2410. 2 plus 4 is 6. 6 plus 1 is 7. 7 is not a multiple of 3. So it is the entire number 2410 is not a multiple of 3. Similarly, the case for 9. If we are calculating for 9, the entire sum, that the sum of digits should be a multiple of 9. That is the rule. That's why these rules are very similar for 3 as well as 9. So we can conclude that the entire number would be divisible by 9. But in the exam we won't get a direct question of whether that number is divisible by 3 or 9. In the exam, typically the question would be, will be given a number 4y3. Y is a digit of this number, so it can be 403, 413, 423 or something like that. We'll be given this number and we'll be told to find whether that number is a multiple of 9 or not. So for in this case, we know that the entire the sum of digits should be equal to 9. So we know 4 plus 3 plus y, that is 7 plus y, should be a multiple of 9. So it can be either 9, 18 or something like that. Y has the sum should be equal to 9. Since we have 7 plus y equal to 9, we can conclude that y is equal to 2. This is the very typical basic question that will appear in your exam. Next cluster that comes is 5 and 10. These are the most simplest divisibility rule that we have, that if a number is a multiple of 5, if you want to check that, the last digit is always 5 or 0. Even if you consider the table of 5, the number is always 5, 10, 15, 20, 25, 30 and so on. So the last digit is always 5 or 0. And in the case of multiples of 10, the last digit invariably remains 0. That is 10, 20, 30, 40 and so on. Next cluster that comes is 11. 11 has got a unique divisibility rule, that is, if we have a huge number and if we take the sum of odd numbers and sum of even numbers, and if we divide them, consider this, these are the odd digits starting from the right side. We have to start from the right side. A, B, C, D, E is a number which has got 5 digits, A, B, C, D and E. We start from the right side, we add E plus B and A. In this slide, I have shown these numbers as bold. So these are the alternate digits, E, B and A. If we add them, and then we have to subtract, these are the odd digits, and we have to subtract the sum of even digits from this. Even digits would be C and D. So if I add C and D and I multiply and I subtract it from A, B and E, we'll get the number. Consider this example over here, 1364. In this number, starting from the right side, I have 4 and 3 are the odd digits, and 6 and 1 are the even digits. If I add 4 plus 3, I have 7, and I subtract 6 plus 1 from them, I have 7. So 7 minus 7 will give me 0, which is a multiple of 11. Multiple of 11 in the sense 11 into 0 is 0. So 0 is a multiple of every number. Similarly, in the next example, I have 7 and 9 as odd digits, alternate digits. We have to consider, starting from the right, we will consider the alternate digits. 7 plus 9 is equal to 16, and the other number is 3 and 2. The even digits would be 3 and 2. So if we add 3 plus 2 and we subtract from 7 and 9, that is 7 plus 9, 16, minus 5 is equal to 11. So yes, 11 is a multiple of 11. So that entire number 3729 is a multiple of 11. Similarly, now please pause this video and try to internalize these numbers with some other example by taking on your own. Yeah, welcome back. Consider this example. Now try to solve this number to 25,176 on your own. Welcome back. In case of 25,176, we have the alternate digits starting from the right as 6, 1 and 2. Adding 6, 1 and 2, we have the sum 9. And similarly, our even digits would be 7 and 5. 7 and 5 together make 12. So if we subtract 12 from 9, we have the answer minus 3. Minus 3. So the minus 3 is definitely not a multiple of 11. So this entire number won't be a multiple of 11. Similarly, we have rules for composite numbers. Consider a composite number. We know what a composite number is. Any number that is a multiple of a prime number. Consider numbers like 6, 12, 15. We have the rules for such numbers is that in case of 6, if the number is a multiple of 2 as well as 3, 2 and 3 both, then that entire number would be multiple of 6. Similarly, in case of 12, if that number is multiple of 3 and 4, both 3 and 4, then that number would be a multiple of 12 also. Similarly, in similar terms, the number is multiple of 5 and 3, then that number would be 15. For now, take any example, take any multiple of 12, say 72. 72 is a multiple of 3, yes, 7 plus 2 is 9, it is a multiple of 3, as well as it is a multiple of 4. So every multiple of 12 would be a multiple of 3 and 4. So we can take this rule and apply it to some bigger numbers also. Say consider if we want to check whether a number is multiple of 21. So we know that 21 is a multiple 21 equal to 3 into 7. 3 into 7. So if a number is a multiple of 3 as well as 7, the number has to be a multiple of 21. Let's consider 42. 42 is a multiple of 7 as well as it is a multiple of 3. So it has to be a multiple of 21. We can also apply these rules for numbers like 18 and 24. But what happens over here is we take 18 as 9 into 2. And we also have 18 as multiple of 6 into 3. So what should be multiple? What should we check? It should be a multiple of both 6 and 3, or should we check is it a multiple of both 2 and 9? Always and always keep in mind that these two numbers, when you split that number into two parts, the two numbers 9 and 2 should be co-prime numbers. Then only the number would be a multiple of 18. Consider why I'm saying this, that it is not a multiple if we check 6 and 3, is that consider the number 12. We want to check whether 12 is a multiple of 18 or not. But 12 is a multiple of 6 as well as 3, but it is not a multiple of 18. So this can give you errors. Similar, also consider 24. 24 is a multiple of both 6 and 3. In same case with 30. But 30 and 24 are not multiple of 18. In other cases like 24, we have several numbers, 2 into 12, that's 4 into 6, and 3 into 8. So in among all these, 2 into 12, 2 and 12 are not co-prime numbers. 4 and 6 are not co-prime numbers, but 8 and 3, yes, it is a co-prime number. So you can check whether if the number is multiple of 3 as well as 18, the number will be always a multiple of 24. Now pause this video and take certain examples, and you'll check that 24 into 4, 96 is a multiple of 8, that is 8 into 12, and also 3. So this rules can be applied to any big composite number, but only keep in mind that when you split it up into multiples, the two numbers have to be co-prime. Next cluster that comes is 7, 11 and 13, that is the cluster 5. What we did in cluster 4 for 11 is very much similar to what we'll do over here. In this number, consider there's a huge number of 12 digits, in which I've generalized that number as A, B, C, D, E, F, G, H, I and J, K, L. Okay, we'll make a group of 3 numbers starting from the right hand side. In 11, we were making a group of 1 alternate numbers, but here we'll take alternate 3 numbers. There's J, K, L would be one number, D, E, F would be another number, and similarly these two will form other group. G, H, I and A, B, C would be the second group. So what we need to do over here for any of the numbers 7, 11 or 13 is we start from the right hand side, we add JKL and DEF and subtract ABC plus GHI from that, and if whatever the sum we get over here is, if this sum is a multiple of 7, then the entire number ABCDEF, the entire number would be a multiple of 7. Similarly, if we are checking for 13, this number should be a multiple of 13. Consider this example that we have taken over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is one huge number. Okay, so if we sit and practically divide, it won't be feasible for us. What we'll do over here is we'll take groups. Starting from the right hand side, we take groups of three digits. Then we leave 3 digits, and again we take 3 digits. We have to add 789 plus 123, 789 plus 123, and minus the middle digit 456 from it. We get the sum as 456. Now if 456 is a multiple of 7, this entire number 1, 2, 3, 4, 5, 6, 7, 8, 9 would be a multiple of 7. Similarly for 11 or 13 also. Please try to take some few examples on your own and check whether that number is a multiple of 7, 11 or 13. The next cluster that comes is 7, 13, 19, 23 and 29. These divisibility tests are very unique in nature, in the sense let me directly take an example and then we'll come back to the rules of other numbers. Consider this number 13006. If we have to check whether this number is a multiple of 7, what we do is we take the last rightmost digit, we cross it out, and we multiply it by 2. So we get over here is what we get over here is 12, and we'll subtract 12 from this entire number 1300, not the right digit but from 1300. So we are left with 1288. So again strike this digit 8 out, and we subtract 16 from here. How did we get 16? That is 8 into 2. We get 16, and we have to subtract 16 from the rest 3 digits after striking out the rightmost number. So subtracting 16 from 128, we get 2, 1, and 1. Strike 2 out again and subtract 4 from here. That is 2 into 2, 4. 11 minus 4 will give us 7. If this last digit that we get is a multiple, if it is 7 or 0 or any multiple of 7, that is 14, 21, then this entire number 13006 is a multiple of 7. That's why I've named this rule as x minus 2y. What we are doing over here is that entire number is x. We take the rightmost digit and we multiply it by 2 and subtract it. We take the last digit 6, we multiply it by 2 and subtract from the remaining number. Similarly, in the case of 17, we'll multiply the last digit by 5. Let's take the example over here. 1111333. This is our number. That is 1,11,333. We take the rightmost digit, we strike it out and multiply it by 5. That is, we get 15. If we subtract 15 from this number, we'll be left with 8, 1, and 111. 111. Again, strike out the rightmost number and multiply it by 5. That is, we'll get 40 and subtract it from rest of the number. We're left with 1071. Again, strike out the lastmost number and multiply it by 5. We strike out 1, we get 5, and we have to subtract it from 107. We are left with 102. Now we know that when we multiply 17 by 6, we get 102. So 102 is a multiple of 17. So we can stop here and we can say that this entire number is a multiple of 17. Similarly, you have to internalize all the rules for numbers 7, 13, 17, 19, 23 and 29. Thank you.